Right, hello everyone, welcome to another stream. How's it going? So yeah, we're very, very close to finishing up this build system. Basically, we've got this build system where the idea is that it runs in the background, right? So it compiles and runs the build script, such as the C build script. It runs in the background, right? And anytime you make a change to the file system or the files that it's watching specifically, it will then trigger rebuilds. So we've basically got it up and running for shaders, but we need to get the rest of them working. So if we go quickly to a shader, let's just say scene shade or something. So if I save that, see here, it's got nothing here now. We'll save it. Right, it then reran. Oh, okay. It seems like it's ran the wrong thing. But yeah, we've still got things to fix and bugs to find and to fix. But we're getting very close to it actually working. And the whole point of this system is that it does code, it does assets, and when the build is completed successfully, it sends the game a message and it says, "Hey game, these things are finished. Rebuilding. What do you want to do with it?" And the game will take it and maybe reload some assets or the game itself. And so the whole code reload, like, so basically the game doesn't have to watch the file system, right? The build system's already doing that, and the build system just tells the game, hey, this stuff is done. So there's no, it kind of gets filtered through the build system as well, which is nice. So only things which are actually done and built, the game will know about, and it will know about it when they're actually done. And rather than just seeing operating system writes and then hoping it's done, right? So yeah, it's kind of cool. So yeah, today we got a bit of a list. We want to do some performance testing because yeah, it would be great to see if there's any things which are clearly bad and we can fix that. And also, anytime we find something which where the build system's getting a bit weird, we can always just do a dash time when we run the build script and see some metrics, right? That'll be handy to get that in. We also want to get the rest of the commands working. And then obviously there's that inter-process communication with the game. I don't think we'll get here today, but maybe we'll get there tomorrow in tomorrow's stream at 2 p.m. GMT +1. But for today, we'll probably just be doing these two things and fixing some bugs. If you have any questions, feel free to ask away, and I hope you're all having a good week so far. Right, let's start off with a quick prayer and then we'll get going. Father in heaven, we thank you, Lord, for this day. We bless your holy name. We thank you, Lord, for being our great provider, giving us this life, Lord God, and keeping us alive and well, and our family alive and well, especially through times like COVID and any other strange times we've had in our life. Thank you, Lord, for keeping us alive and our families well too. Lord, I just pray that you help us all get to know you more, get to know the truth, help us find the truth in this place where there's lots of falsehood, especially in this time of AI going around on the internet and just making up a load of rubbish. I just pray, Lord, that you help every one of my viewers get to know you, and ultimately, Lord, they get saved before they pass, and their family too. They get to spend eternity with you in heaven or on this earth in the millennium reign of Christ and the earth too as well. But Lord, I just pray that if anyone's struggling with anything in their life, going through some hard times, I pray, Lord, you attend to their needs and ultimately just show your hand in their life, such that your name is glorified. And Lord, I pray you help me as well with this project. Help me be on the right path. Help me be on the right route. And lead me down a straight path and not a windy path. And yeah, just pray ultimately, again, your name be glorified in this project. I lift up your name, Heavenly Father. In Jesus' mighty name we pray. Amen. Cool. Right, let's get going. So let's start off with something which is kind of fun, right? Producing numbers, right? We all like numbers, right? Performance. So when we have performance numbers, we can have a fun game of making number go down. Number go down is usually quite fun, but yeah, let's just have this available. That way we can always just do it. So in the build script.h, there's a global structure. I don't usually like putting booleans in here, but we're going to do another one. It's going to be called time. So we've got a verbose flag, and now we're going to have a time flag. So basically, we're just going to have a few little things up here. So here's like build debug. Interesting, isn't it? Do we oh, okay. Yeah, that should probably be a anyways, a flag or something, but it doesn't really matter. Doesn't really matter. Okay. So I'm probably looking for some kind of like time start or something. So I reckon in that header file, we want to store probably like a stack of timestamps. Now I don't know what they are. Yeah, I think you just use the performance counter thing on Windows, isn't it, basically? So type def strut build. We can just call it a profile. Something like that, one of these guys, yeah? So, you know, you could abstract that on different platforms whenever we try and get this working on other platforms, right? Not really caring about this, you know, porting it to other platforms yet, but it's isolated enough to the point where it'll be quite easy. So I think it's like get performance counter, get performance frequency, right? So C Win32 profile code get performance counter. Right, let's just get some code for that. So I forget what it is. Large integer, right? So it's obviously U64. So we'll just call it the no, we'll call it let's call it T, I guess, or raw. And we'll just have a stack of timestamps. So we'll stick them somewhere. That's interesting. The file DB is not down with these guys. Let's do that. These are all the different subsystems, right? With the file database, which stores all the timestamps for all the commands, all the input files for the commands, and so it's similar to like the ninja.log file, basically. File index, directory watcher, the DAG that gets built, so the dependency tree basically, and the executor grid. So this will just be a series of profile timestamp stack, and we'll have a count on there as well. So I don't know how many we'll have, maybe maybe 16 is enough. I don't know. Let's just start there, right? Let's make it really easy. Just bump it if we need it, right? So basically we'll just do a gbuild dot profile timestamps stack equal alloc profile timestamp. So it's alloc array. Hey there, Caribbean. Did Pope bless Anthropic's Claude? Oh, that's an interesting thing. Yeah, didn't the Pope come out against AI? Yeah, I remember it being a very long thing, and I watched a brief video on it as a typical Gen Z. You know, I'll show my Gen Z side. I'm kind of like half millennial, half Gen Z. I'm like on the border. Um, yeah, I forget because typically the Pope doesn't make the best calls, right? But then I read the brief summary and I was like, hang on, it's probably a good take. But then I was struggling. I'm trying to think what's the motive behind it. I think his take was something along the lines of, what was it? Yeah, what was the Pope's? Da, 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 da. Yeah, I forgot what he said in the end. Yeah, but he said about using it in war as well, I think. Oh yeah, one of the Anthropic guys wrote it with him. Yeah. So I'm curious why he's saying some of this stuff. What's the motive behind it is my question. Because maybe he's trying to come out against AI such that they can control it. Right? That's my guess. If it's got some bad intentions. Pope is American, Anthropic is American. Yeah, I remember that actually. Yeah, but the Anthropic guy and the Pope kind of wrote that thing together, didn't they? Anyway, it's just weird. AI is basically going to evolve into the unholy spirit, but we'll just wait until that happens. Meanwhile, it's just going to keep using 500 mils of water every 10 to 100 prompts, and people are going to just throw everything to do with the all the eco-friendly stuff they've been complaining about for years out the window, and not care about it. I'm surprised that's not getting a bigger thing from all the people who are saying care about the planet. You know what I mean? Anyway, apparently we were supposed to be worrying about the planet being unlivable by 2050 or something dumb like that. And then we're like, if that's true, then why are people not complaining about AI taking up all this energy? It's just strange. We live in strange times. Hey there, Stipe. Welcome, sir. How you doing? God bless you both. How's your week's been? Ethics get in the way of convenience. Yeah, that's the thing, though, isn't it? It's like people typically trade the productivity increase for over lots of these benefits and stuff, right? It's like you wouldn't want to stop having warm showers, right, to save the planet, would you? You know. Okay, thus far. Hope yours is going well. Awesome. Like the old English using there, the thus. Let's go back older. Anyway. Yeah, mine's not bad. I'm just a bit tired, you know. I'm still recovering from holiday, and yeah, I've got a stack of sleep. Like, I got one of these stacks of sleep, basically, and it's kind of full right now. Push. So I'll push a timestamp, and I'll pop it. Do 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 do. Do we put the Yeah, we might want to put the string in there right away. And then, yeah, we'll do strings on both. Because that way we can verify the string as well. This is gonna be cool. Hang on. That'd be fine. Where's the the assert bounds? One of these boys. This is what I wanted. This is what I wanted. Right. So insert index equal g build dot. Yeah. Then we'll eventually do like a g build dot. One of these insert index. Right. Lovely. Okay, so we're gonna grab a profile timestamp. Let's just call it T, I guess. And we'll say T name equal name. And then T raw is equal to get performance. Query. Right, even better. That's a good name. Query means it takes time. Get is like meaningless. Right, so we want to get the counter. Just cast into a large integer. No biggies, right? Ought to be good enough. And I think it returns a... That'd be fine. Right, so you want to call the frequency once, and then... Yes, so we want to store in the build as well the frequency. So it'll be profile timestamp frequency, that. So query profile performance frequency cast into a large integer again, g build dot one of these guys. Yeah. Now when we still got the stack, the name goes in there. So when we pop, we obviously get we assert that g build, the count is equal to something. Right, we'll just say pop has been called more than push. Then we grab. Let's get rid of the const. I remember in this code base I was doing no const whatsoever. It's very small. Oh, actually there's const up there. Oh well. Sorted. Yeah, that's a great thing to put in a code base, you know, just get rid of const. Be amazing. But yeah, const is alright for pointers sometimes, so anyway. So we want to fetch the tail. How to take the address. Right, so the idea is basically, again, do another assert. And this assert is going to be a string compare between tname and name. They have to be equal. And we'll say, you know, we'll do pop with the name string is supposed to be this string here. So it'll be name, then tname. So that just gives a little bit of safety there so we don't screw stuff up. Obviously it's adding some extra cost and things, but it should be fine. Then we simply just do the maths now. So we can do a get performance counter here. We'll call it now. Then this is in what? So calculate in milliseconds. So it's probably in micro. No. Yeah. Is it in micro? Alright, now I'm not trusting this thing. Query. Because it does, yeah, but so you divide it by a frequency. Yes, in micro. Right, that sucks. Do they have nano? Anyway, it's fine. But yeah, I wonder, because on Linux there's nano, isn't it? I forget these things. Right, so Win32 nano. Run units of 100 nanos. I don't know if they do, but it doesn't really matter. This is probably sufficient. Because we're just in it for the build system, right? Now, so... yes, so it's simply... so it's now take the other time. Then times by 1,000. Yeah, so we could probably do... we can probably just display a few different times, right? You know, there is that thing where... yeah, and we can do it smart. Smart is better, right? So we'll keep it in the micro. Yes, we divide by the frequency part. So divide by gbuild profile timestamp frequency. Yeah. Now, so this will be the microseconds. Yeah. So what is the what is a shorthand A to Z for micro and milli? I forget what they are now. These days. What you do? Yeah, US, isn't it? Of course, right? Because you don't have access to that. That's a Greek letter, isn't it? Yeah, so there'll be a US. And so what we can do is just be smart about it, right? So we just simply say if US is greater than 1, 2, 3, right? That's a millisecond, right? So we'll print out like this, you know, profile then the name, and we'll say it took. So I guess you can do that first. And then here we just do the whole. So that would be ZU, I guess, and then milliseconds. Now you turn into a double, wouldn't you? So maybe actually, so it'd be a f.2f, I think. So this would be, that'd be an else if, so 1, 2, 3, that'd be a second. Cool. And then the rest would just be, so the else would simply be ZU. And then we'll do the special characters, right? These ones. Okay. And voila. Look at that. That'd be cool, wouldn't it? Alright, so now what we can do is, so I guess you could just use like these two things, but equally is quite long and we can't compile them out or make them with if statements too easily, right? So that's this where macros come in. So you just say profile start and you pass in a name, and then we just say, right, if gbuild.time, then build profile timestamp push name, and then simply profile end, and then pop. Yeah. Ta-da! So now we just, we can try it out. So if we see something like, right, so we could say, build the file index. File index build. That's nice. Now we could actually do a scope thing. That would be quite nice. And that's the other way of doing it, right? So you could say, yeah, so you could do a profile scope. So let's go find that in the code base now. Yeah, one of these things. Build script.h, just stick it up here. Okay. So we'll do a start name, end name, then we'll still wrap it in an if. No, we'll do it manually. I think that'll do it. Okay, so we've got this lovely profile scope thing now. So essentially, you just do that and that. But the problem is it's not going to run. Okay, yeah, we can't. Right. Won't run it if the time's not there, so we've got to delete that and go back to using the macros. So it's still going to run it in a for loop though. Okay, cool. But yeah, the only problem with this is it will break when you use the keyword break and stuff like that, but stuff to be worried about. Right, so let's give it a go and see what happens. When it wants to compile, that is. Right, so let's do dash time. Oh, that's not very nice. So I guess you want to move that inside. Right, let's get rid of this then. And we'll put it inside the functions. Not the best, but it's fine. Here we go. Has been called more times. So very nice. So assert. Oh. My assert's not the wrong way around, is it? Yeah, exactly. So expect it to be non-zero. Oh, we never incremented it. Cool. So we just got 0, weird looking T, weird looking ANS. Something clearly wrong there. Yeah, it's probably not handling the UTF-8 very nice. So if we do, yeah, so it was just super quick. So we'll just do US there instead, right? So let's try that out. There we go. Okay. Maybe let's just double check, right? So we do a print now equal, let's just use ZU, let's just do that. So it was now T raw and G build profile frequency. Yes, I think it's just way too fast basically, but it's good to keep it there. Interesting. It's a rather big number, that frequency. But yeah, I guess it's to do with the CPU, isn't it, or something like that. Okay, cool. So we can always test it out. Do like a sleep, see what happens, right? So if we did let's do a sleep, capital S sleep. This is the Windows 1 in milliseconds. Let's do 1,000. That should be 1 second. All right, so do we get around a second? No, that kind of printed a bit wrong, didn't it? So why? Let's try that again. Right, so it seems like you want to do the multipliers and stuff before you do the divide by frequency thing, I think. Yeah, so right, so what does the times go before the divide? Just probably explain how it works. I remember reading about it before, but I just completely forgot. Yeah, so right, so it gets divided and okay, it'll truncate. Right, I see. So what we want to be doing instead is taking the time. Okay, sorry about that. So I want to do a diff. So then, yeah, but then you don't know. Yeah, but that's still a bit strange, isn't it? So, because even if it was in micro ops or whatever, it should be enough, right? To see, you only see him one. Oh, counts per second, that's why. Okay. So that's per second. Right. I see. So you could bring it into seconds and then right, so we bring it to seconds. So 1, 2, 3, 1, 2, 3. That'll do it. So from micro to milli, then seconds. So that'll give you. No, sorry, that will then be in. No, it's the wrong way around, isn't it? So. Right, so this is the unit of counters, if you will, until you get to a second. So I see. Do, 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 do. Hmm. So the problem is we want to know it kind of like the final result. We could just turn it into a double, right? And that just solves the issue. But then you will lose some precision, probably. Let's do it anyway. Let's see how that behaves. Let's just do that. So now what we're looking for is so it'll be dot 0 f. Alright, let's try that out. So that'd been seconds, wouldn't it? So in seconds now. So if greater than 1, then display as seconds. If greater than 0. Right, so 1, 2, 3, cool. So that is now times and times 1, 3, 1, 2, 3, cool. So that'll be right. We'll put 0.2 there anyway. There we go. Perfect. Right. So 1.1 seconds that took, right, to do the build the index. That's not how long it takes. But I put a sleep in there because I wanted to make sure we got it right. So if we put a 100 milliseconds sleep, there you go. It took 104.04 milliseconds. There you go. Ta-da! Cool. So if we do that now, what does that do? Right. So supposedly it takes 2.7 or 8 milliseconds to do that. So it's good to know. Right, so we've got some performance stuff coming now. Right, so how long does it take to parse the file database? We get to know about that too. We're using the time mode. There we go, isn't that nice? And maybe you could bunch this all together to just be like the initialization, but whatever, right? Yeah, how long does it take to initialize? To build in it? What are you complaining about? How's it called more times than push? That's not very nice. Oh, because build time hasn't been parsed yet. Right, how do you do build time? So first you parse the commands, and then you can do the profiling of it, I guess. This is cool. How long does it take to do all that? There's a couple of virtuallocks in there, I think. Maybe we can just make it 1 if we really find it a problem, but so Oh yeah, we're also compiling with well, so now it's a good idea actually to like not even rely on memory allocation. All right, so let's go with that. We can get the frequency there, that'll be fine. All right, let's try that out. Yes, we're also running with the address sanitizer. So actually, we can turn that off. So we can say build.bat. How do you do see rem, isn't it? Yeah, so I guess we could do I forget these things. Let's just get rid of it. We can always put it back if we need it. You know what? I need to know. Batch file variable. I think it's percent, isn't it? So there's set. Right, so set flags equal. Here we go. So and then you do percent flags. I tried to do basically no batch script because I don't like scripting. Shell scripting's horrible. I think that'll work. Cool. So now we can then remove, can we do rem on that and will that work? Right, so now we don't have I don't think we have the address sanitizer on now, which is cool. I think so at least. How do we know? Or we just turn off echo and see what happens? Oh, it's still in there. Right, how do you comment out? Huh. Hang on a minute. Has it said it globally? Damn it. Ah. That's the problem. Set local and local. Ah. The joys of scripting. Right, how do you clear okay, so set flags. There we go. Very nice. Okay, so we've seen an actual difference now. So with it's a bit strange. Yeah, so with the sanitizer, address sanitizer, building it used to take nearly 3 milliseconds. But then it went down to like 200 micros. So yeah, it was like 10 times slower, that one. But yeah, the build index was slower for some reason. Not sure why. Maybe it's a caching thing. Anyway, so we can always put that back in when we need it to do some debugging, right? Yes, the address sanitizer uses malloc, whereas the non-address sanitizer code will use the custom allocator we've got. It's just a bump allocator, not anything special. Right, so now we can get performance metrics and stuff. That's good. I don't know if anything else we want to put in. We can say build DAG. So build DAG. Right, and then we can say like we can also do an overall build potentially. So we can say like, hey, this build took this long, right? So you could be like, yeah, so this would always do a push. So this is just a build. And then, or a start, when you do a continue, I'll just do an end. And when you wait here, do an end there. So we could, you know, do a start again. And a start would happen here after the wait. Process all these events and then go again. So now we can get like how long a build takes as well, which is kind of cool. Oh, that didn't work, did it? Close though. Alright. What's this one complaining about? Right, so this would have gone in here and it would have never started, so you have to start it outside the loop. It's getting a bit messy, but I think it's manageable still. Right, so the build took around 4 milliseconds. Right, good to know. But yeah, obviously as we add more features and things, as we add more things to build, this will take longer, so it's good that we got it in now. We can always do this stuff, right? So cool. That's awesome. So you know you could actually time commands as well if we wanted to. So we could say, have you ever tried Tracy? No, I haven't actually. I've seen it. I do want to get it hooked up to my engine at some point. But yeah, for the build system, maybe not required. But for the game, it'd be really cool. Like, especially doing CPU and GPU through it. That'd be nice. Have you used it before? I've heard good things about it. And it's free, you know. So, like, can't typically go wrong with free. Right, what else we... So yeah, we could say every command that runs, we could take a timestamp and then get it when it finishes, and actually just display it as part of the output. And we could do that regardless of dash time. I don't know. Does that seem like a good thing? Like, let's take a look at it for a sec before we go ahead and move on to the next thing. I want to investigate whether this is a wise idea or not. So this is what we're seeing, right? Running this. But that running happens at the start. It doesn't happen at the end. And we only... Sorry. It's here, right? It only kicks off when it kicks off the process. We don't say when it's done because it's just too much spam otherwise. Actually, let's change it the other way around. Let's do it at the end. No, but I've been looking at it. It's quite nice because it comes complete with a visualizer. Exactly, yeah. So I've seen people hook up GPU as well to it, so it's quite handy. But yeah, I'm looking forward to hooking up whenever I need to profile. I'll probably do my own sort of profile stuff like we're doing now because it's sometimes nice just being able to have a vague understanding of how things are doing with your own system. But I don't know how good Tracy is. Tracy might be quite great where you can actually have your game running at the same time and capture stuff live. I don't know. I need to look at that. But doing some live stuff in your own engine is quite. To get a vague understanding is where I might start, rather than trying to integrate something else. But if that's something else that Tracy is really great, then it's probably a no-brainer just to do that right away. Yeah, so there is a finish. Now, we might. Yeah, so let's just say it finished building. Built. Yeah, let's just say built, right? So built that. And it took in, and then a number of seconds maybe. We could do that. That could be quite cool. So the thing is then, what you kind of want is like kind of a build profile timestamp string, maybe. Bump allocate it. So you pass in a U64. This could be kind of fun. So we would like we need a now. And we should printf. What was that? T roll, there we go, yeah. Cool. So we just bump allocate it right. Now it kind of sucks because you have to yes, we could modify S. Yes, I think we can do a format. Now it's gonna be a runtime format. I think it might complain and cry about it. Maybe. Maybe it might cry about it. I don't know. Sometimes it will say like, oh, this is unsafe. You're like, that's the point. It's supposed to be. Right, so then you can like do your whole temporary buffer thing, right? So you just do a, well, you could put it into a static buffer and then return that. Yeah, that's probably just okay, isn't it? Yes, that'd be fine. So we'll just put it into a static buffer. So we just say s printf, and we'll just call it buff. I guess I'll do the sn printf. You might as well, right? Might as well. Char buff. Let's do 32. Ought to be good enough. Return buff. Now we should make it static. Whereas you can't call this on multiple threads though. At the same time. But unless this ends up being a thread local magically, but I don't think it will. I think sometimes it does that in C++. You have like a static build and then it's like making it thread local for you. It's like really crazy. But yeah, so this is really cool. I like this a lot. So basically we just go over to the executor, which executes the so the executor, it's just a thread that runs in the background and waits for stuff to be done and then dispatches new stuff. So as soon as it does one of these, we can take a counter. So on the task, we'll store a start time. So it will be query performance counter, cast it into a large integer pointer, address of task start. So we probably want to do that as close to the start process. Okay. And then here at the end, we can then do a build profile string, right? And then we'll do a task start, and there we go, right? Oh. So where's all these guys? Yeah, so I'm not noticing any SPIR-V files being compiled anymore. I swear though, I'm pretty sure they're happening before. Right, alloc A sometimes fails because I do a fixed address. It doesn't like it. It complains when I do that sometimes. So but virtual alloc, I made it a fixed address so we can debug between. So if I have a pointer in a previous execution, it will stay in the exact same place next time, providing the program runs the exact same. So I can put some watch points in, but sometimes it doesn't. Sometimes like a standard library will get placed there in memory and it won't work. But yeah, this is cool. So we're getting like times now for builds. So built in this and it built that, yeah. Cool. Pretty nice, isn't it? Now, this is just the dependency file. Like, why isn't it building the SPIR-V code anymore? Oh yeah, because it knows it's not changed. Yeah, so I guess this is one of the bugs, right? So I've deleted the actual output shader. So like, if that doesn't exist, it obviously needs a build, right? It doesn't matter if the input files. Yeah, so that's something that needs to happen in the system. So there's a needs build. So this is in the queue for execution on the DAG. So it goes over and finds all of the commands which have no creation command node. So what's the way of saying it? Yeah, where a command where the inputs. Wait, is this even right? Let's double check the thing. So we go over all the commands, we look at the inputs of those commands, and if all of them are, if all the inputs are not created by another command, so they're kind of like already exist on disk basically and they're not part of the build process, then these ones, we definitely run these. Yeah, that's right. So then we go over all of those and we see if we need to build them or not. So this one goes over all the inputs and tries to see if the input needs a build by checking the timestamp. But we also need to build like if the output, what's the way of saying it? If the output yeah, so if any of the outputs don't exist in the file index, I imagine that might be. We should probably index the build directory as well, I imagine. Do we do that? Yeah, we do. So, yeah, I was hoping to get rid of that and just do file index exists. That'd be much better. Be quicker, it's just cached in memory. So yeah, so when we try and build shaders, if the dependency file doesn't exist, make the dependency file. And then in the next iteration, we build the DAG again from scratch. We do the actual, oh, why is it called depth file? It should be called depth file, the actual shader. Cool. Right. So that needs build is better off checking the outputs first. So it should check the outputs then the inputs. So if not need build, then we'll check the, oh no, it needs to go over the inputs as well. Hang on, why did it do the break? I thought I had to do the get or insert. Oh no, I did that elsewhere, didn't I? Yes, okay, no worries. Yes, we could check either really, I think. It's not needed to check there. Yeah, check the outputs because there's probably going to be less of them. And we want to just say, right, if the output file does not exist, then it needs a build. So that would be file index exists. So it'd be file dependency node path. So if that does not exist, build cause the build hash. Hang on a minute, what's going on here? This is completely wrong, is it? I'll look at it in a minute, but right, build cause. This is C for the command node. And the build cause is the fact that missing output file. That's why. Okay. Where's the F? Nice. Yeah, so is this one right? So build cause, so it's this command. And the reason is because this timestamp is less than that timestamp of the file. So it's the wrong. Oh yeah, the command hash will just be here, C command hash anyway. Cool. Right, so give that one a go. So now what it should do, the spivvy files are not there, and it should notice that and then build them. Right, it did build them, but it didn't show up in the thing because it's not got the verbose log. That's cool though, so we do a -v now. Man. All these times, not a fan, but there we go. I used to compile all my shaders in my custom compiler all in one go. And I can see all these just accumulating into madness when I've got like 200 of them, like I had in my previous thing. Yeah. But anyways, right, here's the verbose output. So if you look at the reason, it just keeps going, man. What's this? Yeah. Not very good. So with the verbose, it causes stuff to take, to like, no, wait. So I feel like what's going on here, it's not because of the the verbose thing. It's because I deleted the files, I think. Yeah, okay. So what's going on is we're using the file index now. The file index is not picking up on these things for some reason, and I know why. Okay. So what happens is we reset the DAG, we try to build the DAG, and while we're trying to build the DAG, we go, do these dependency files exist? No, they don't. So we then end up pushing on a find dependencies command, which basically says this DAG is poisoned now. Don't execute it until we have all the dependencies, but I'm going to go and try and build it still, see if I can gather more things to find dependencies for. And then because we're not allowed to build it because it's basically poisoned, we wait for all the find dependencies to finish, and then we continue again. Now, here though, we there should be some directory watch events now that have happened. So what we should do is probably move to here. So save the file database. So we'll say go to wait, maybe. But if that's the case, you're basically just saying, right. So the allow build, dump the DAG, execute the DAG, and do the wait for file changes thing as well. That should do it. Alright, we'll try that out. Right, so that built the SPIR-V files there. So we run the -v to get the verbose output. Cool, that's it. So it built the dependencies. No, where are you now? Right, so it's not watching the build directory, unfortunately. We need to watch those directories as well. So the standard, when it writes to a standard out, we need to watch that directory. So where is that? So what tells, right. When do you push a new file in the database? Yes, this is an output. So yeah, I think we'll just call, no one call push, we'll do a watch. Cool. Right, that built the SPIR-V files there. What was the reason? Excellent. Here's the reason. The cause for running this build with this hash, so the hash of the build command, is the output file. We're missing the output file SPIR-V. Amazing. So I'm not really a fan of the fact it's called GLSL SPIR-V because that's not what it was called before, so we'll sort that out quickly. Is the build system kind of like gonna be, or do you have a scripting language? I'm not sure what NB is. Wasn't that what deciding did at some point? Um, so mine's not a scripting language. It's just purely C, right? So it's probably similar to this. Um, but yeah, it's Clang.c, whatever. Yeah, I remember having my build scripts a long time ago and see. I think I told Tesodin about it, and then he did this in the future at some point. Gave me the idea, I think. This is the first time I've taken it this far into being a proper one of like a watcher. I've told someone else about this idea as well, and they've done it. It's cool. What did he do in the end? No make. Yeah, this stuff is always horrible. Right, so only see. Yeah. Right. You're not making. Yeah. I was making claims it was a good idea. So the user of the build system implements. Yeah, exactly. So you just make a simple batch file, which is a one-liner. Unfortunately, got more than one line, but basically a one-liner, where it just compiles the build script and then runs it, and then voila. So it has got a DAG though, so it is kind of declared. Like you write little. This is you. I'm saying like all of the GLSL files, right, in the code base. And I've got a thing where I look at the file index because we pre-index the file system, and we add to the index whenever we come across new files. So we go over all those files that we come across based on that input filter, and basically just like compile my own command string, and then put it into a dependency tree basically. And then that dependency tree gets executed. So it sorts out, it figures out what's parallelized basically. Does this one have a DAG, or is it more of just commands that get executed? Does it do dependencies? Does it use like the depth file in the C? Okay, this is very, very small, so probably not. I don't know though, maybe. Oh, and the .h file, right, of course. Man. Yes, it doesn't implement a DAG, but I wonder if it handled dependencies still. So mine, before I just rewritten it to a DAG, I just did it as like barriers. So obviously it ends up like flushing, wait until everything's done, and that therefore CPU cores will be running idle for a bit. But with this DAG, they'll keep being fed with information so long as there is stuff to run that's not got any dependencies going. So it's kind of cool. There's like a sync thing, basically. Run async. Okay, so maybe it's like a barrier style approach because it's got sort of an async thing. No, it's old API. Anyway, that's got a lot of versions. They did really work on it for a bit. That's cool. But yeah, I don't know. It's probably not like it in many ways, but yeah, it's similar to the fact it's C, right? And you see, right? I've had a pet peeve for a long time that build systems are not written in the same source language, and they're just so annoying because they take ages and super complicated as well. And the idea is just to make something kind of simple, but also scales as well, right? That's what I want to. And I want to have something which runs in the background, right? So this, I'm making it fast to boot up and get going, but also it's gonna be even better when it's just running in the background. You change a file and it just rebuilds the stuff on the fly. Obviously, that can have some bad knock-ons, right? You can end up like moving loads of stuff and not knowing exactly where you want to put it, and you end up basically rebuilding all your assets and then and code and stuff, and then you move it again, and then your PC keeps rebuilding stuff again. So there's not there's gonna be some problems, but I don't think that's really gonna. I don't think I care about that too much. Right, so where do we do GLSL? File name. Right, this is interesting. So I think I would like... Yes, the file name includes the extension. Oh, but it used to not include the extension, didn't it? Oh, yeah. Yeah, so we could pop extension then. Does the engine use GPU compute? Yeah, it uses compute, but not for main rendering anymore. You use compute for basically everything besides the main geometry render. Alright, where's the input file at? Oh, okay. Somewhere else. Cool, so we do want to pop. So it'd be path pop. So I think it's 5 less. Alright, let's try that out. So we delete. Does not imply a shader stage. Let's see what the file name actually is. Yeah, it does. One, two, three. I'm confused now. Right, so we're saying P plus... Oh, we should be saying file name, that's why. That P thing is rather dumb, so let's call it input. Don't just keep on building, please. What have you done? Right, so that's drops the GLSL output now. So where's the GLSL? Right, so this one. Right, file name. With the extension. Hmm. So what changed? It was running just fine before, so it would have gone into here. It would have added it to the watch directory. Yeah, we'll do verbose and then check the watch files that it does. The watch directory is build shaders. So what will end up happening is when does it queue? Yeah, so it queued many of them, right? Why? Why was it working before? So this worked before, right? Just double checking. Okay. So I've only changed the SpearV name. Like, if we were to put this back here with the extension, does that work? No, that one keeps going crazy as well. It's not necessarily because we're getting rid of the extension, if you will. Right, let's see what that does. Oh. This one's not working either. Right, it might be something to do with the watch. The watcher, maybe? Hmm. Okay. So there's some other problem with the system then. I guess this one could technically work then. Right, so this file exists. This search here is not working for some reason. So we want to probably log out in the verbose thing, like all of the strings that we added in. So a log v info, right, file index. What are we doing exactly? So we're doing like a string format path. There we go. So now we can actually search and find that string that we're looking for in there. So we're trying to find these sort of .d files. Right, so we do the verbose. Right, so we're looking for, let's look for this file. .d version of it, yeah, so can't see it anywhere. I did a -v. Yeah, so follow it's inserting all these, right? Stuff that's in the build system. So it seems like the watch, like it should be getting watched, but it's not. Right, so why it probably worked the first time is because I didn't clear the directory. So when I don't clear the directory, it will pick them up. But when I clear it, it doesn't pick it up. So we do a watch directory somewhere. So it executes all the find dependency versions. Where's that? -m. It does all of these guys. And there'll be another DAG build somewhere. Here we go. This is the next phase. Then ends up doing find dependencies again. But it hasn't. Yeah, watch directory. It's done there. Build shaders, right? So why? Yeah. So I think that's the thing I haven't. Right. I think I see the problem. So when we add a new watch directory, I think we have to wake up the. So I add it to the completion port. Right, let's see if AI can help us with this. So I do this. Do I need to wake up my polling thread? Which is stuck on this guy. Blocking on this guy. That's the question. When you associate an active file handle with the completion port using this, it's passive. Right. So why then doesn't it wake up with new stuff? Is it because it's a creation one and I didn't pick it up, right? Maybe it's a create and not a modify, and I'm not picking it up. Right, so let's see. Is file action modify returned when a file is created? Let's just say that. Is almost always. Dun dun dun. There will be no modify. Because maybe that's what's happening. Several cases you receive an element, but absolutely no. Whether the modify triggers is dependent on creating 0 byte empty file, restrictive notify. Moving or renaming to monitor directory. Interesting. Right, so I think this might be the issue. So let's give this one a go. Called added. Right. So if it's created, I guess it just goes with a modified. And I wonder if, okay, Oh, that built them. Yeah, but that's because we had them already. Right, so let's try from scratch again. No. Just doing the depth file again, keeps going round and round and round. Oh, that's because we haven't, there's a special, where is it? There's the flags somewhere. Where are you? I think it's when you create the completion port. Ah, here it is. Yeah, this one. We're going to issue one of these. So we want to know creation and how do I listen to add, remove, and modify events? That's what I want. So file name change, adds or removes, catches additional. Catches the save and close modification. Yeah, so the last write, that's what we want, is the last write, not the individual changes. But yeah, so I guess we'll do change file name and directory name. Let's just give that a go, see what happens. Right, let's delete all the dependency files again. Hopefully that works. What are you complaining about? Oh, that's not very nice. Multi-cursor. Still no work, unfortunately. So I'd like to print out some of these events. You know, maybe I could say found event. So info action file name. Or path, right? It's a long. There we go. Right, this is cool. Right, what's this? Interesting. GLSL D. Oh no, that's just because it's the past ones. Right, hang on. String format string p. Right, let's try that. Just reusing the same buffer, I think. Right, so I think it's doing an event now. No. Okay, so it appears we've got some crazy stuff going on. So I'd check out the file database. We've probably got a lot of those crazies in there. No, we don't. Okay. Yeah. This is interesting though. A little confused. Oh, it's giving me... Ooh. Yeah, that was after it was normalized. Right. Ah, that's a crazy bug. Man, what a fail. What an epic fail, honestly. That might be the reason why it didn't pick it up, so it's passing the wrong string back. Okay. I thought I was there. Still something else. Right, so let's see what this is. Let's see what we got. Right, we still have some issues. So what is the path? I guess we gotta look at file name next. What's that gonna do? Alloc array, right? So what is path then? So yeah, it still does it those sort of .d things. Now if I scroll up further, they actually start out all right. So is SFM print? I thought this null terminates. Maybe it doesn't null terminate. That would be annoying. Does smprintf null term on Win32? Right, it seems like there's not a null terminator happening for some reason. Maybe because file name is not null terminated, but it is. Right, so you get the length. If you want out length. Seems alright to me. Although maybe... Yeah, that's alright. Okay, so file name. Let's look at file name as well. So yeah, file name has a big old problem as well. So it's something to do with the event buffer. Maybe we're... It's just something weird going on about it. Right, so these ones were kind of okay, but then this one has an issue here, right? Yeah, so file name is the culprit. The question is though, is it because of the conversion code? So how's your wide string? Is it a WS? I guess. Right, if that's a problem too. Yeah, okay, so it seems to be more to do with this event. Right. So yeah, it's not, these are not null terminated. But then I'm handling that okay, I think. I've got the file name, right? So then I'm making it null terminated. Right. So there's something else going on. What could that be? So let's double check this code. I'll take a copy of the events. I get the O. The directory watch store, yep, so. Right, so when we say watch, we create a file. Oh. No, that's fine. Yeah, link it up. Allocate. Is zeroed memory, right? And then issue. Yeah, that's okay. So after this get completion queue, this directory watch structure events shouldn't be written to anymore. So we copy them to a local buffer, then reissue it, right? Now we iterate over the local copy. We simply yeah, so we do all these bits, right? If the next offset's 0, if not. Right. Pretty sure. How do you iterate? Let's see if it's got some sample code. It's in the... Oh, okay, you can use the EX version. Hmm. There's so many different configurations of this stuff. Yes, it's just advancing the pointer. Ooh. Isn't that interesting? We didn't divide by the... There's not a length of characters, it's a size in bytes. Right, that's buggered me up. So divide size of wchar d. Right, let's try that out. Not quite it. Right, so what we're gonna do is I think it's an int. Ooh, that looks better, right? It's just it's not got these corrupted ends. Oh, that's really good. Okay, so that's a proper string now. So what was the other one? So we tried. Yeah, so that's good. So we'll copy that and just in case. Now we go back to P. Yeah, there's been a few bugs actually. Right, so the watcher is now reporting the right file path. Lovely, that's what we want. So this should be reporting that this file has now changed. So it should now exist. Right, so let's follow this through. So this is going to... right, so that was on the directory watch events. So it's done some waiting. Grabs it. It's going to then say that it's been updated. That's not going to go into the file index, is it? No. How do we get into the file index? What ones do this? Oh, basically nothing. Good to know. So when we discover discover watch, right? So any added, like created ones, we want to do a file index insert. So we'll insert the e path, and I guess we'll do a fall through here. I think that's what we're missing. Hang on, let's get that. Right, let's just pop it in here somewhere. Ought to be good enough. Look at that. Ain't that good? So it even puts those in the file index as well. So I don't have to keep asking the file system like, what's the state? Does it exist? So the whole idea is we keep an index. And there we go. So now that's actually working. So if I were to delete this this .bv file, what happens? So it was waiting on changes, it then built another DAG. Then it said, we're missing the output file. It queues up the command to build, waits for the changes, and it's starting the command in the background. Yeah, that print is a little bit too early. It's false. So I think I want to sort that out. Does the build? Yeah, let's sort that out a bit. I'm not. And then these files end up. Oh yeah, and then the new file gets inserted. Oh, right. yeah, it builds and then it marks it as successful in the file database. And then this file gets inserted into the file index, tries to build again, nothing needs to be done. Cool. That's very great. So what's next? That's awesome. So if we, yeah, that waiting thing. So when we allow a build, we queue for execution. Now allow. So reset will set it's true. Perfect. So allow build. So if the build was allowed, we'll say, hey, we're waiting for changes. Right, if not, it's just going to go straight past it. That's the more correct place to put it. Cool, so that's super great now. I'm happy with that. So let's try it again. This is without the verbose stuff, right? So we can literally just go over to, I don't know, scene shade, right? Just save it. So you see there's nothing here, yeah? So we'll save it. Waiting on file changes, built. That doesn't seem great, does it? So that's not very cool. It would be nice if it logged when it's actually waiting. So we can sort that out quite easy. So what we actually do is take this, go into the directory watcher, and simply put it here. But we do a lovely check, right? The lovely check, atomic load, detail, and then if detail hey there, Chris. Do you compile each file separately or using any builds? So for shaders, each file separately because shaders don't really have the option to do that. But I'm doing a Unity build for, so a single compilation unit is the other name for it. I do that currently for the whole game, which includes the whole engine basically. I'm thinking about splitting that up because it's taking longer than like a few seconds. And yeah, like my big goal would be like to do a custom Windows header or something like that, and a custom Vulkan header for just the stuff I need, because that stuff is not going to change much, right? And then when I need to change it, I can just put like an if def around the custom thing and be like, right, if I'm trying to write a new feature, I go into a sort of development mode, and that includes the big old header, windows.h, and then, or if I'm debugging it, I can go into that dev mode and see if my stuff is broken it. But I'm thinking about going that so I can go back to using single compilation unit. I'm not sure yet. You have to see. It's currently only doing shaders because we've just been trying to get it to work, but I'm literally just about to get it working on the C builds as well. So it'll do assets as well. It's a proper system that does everything. That's the plan. Just trying to sort out all these bugs and stuff and make it work the way I hope it should. Yeah. Out of memory. Hang on a minute. Because Beautiful. So if I change scene shade, it did a wait again before it built it, but like, why does it do that? Let's see if we can investigate. Right, here we go. You ready? Right, so it does a... Yeah, so it waits. So it says build DAG, then builds another DAG. Hang on. Right, so maybe it doesn't always happen with those sort of waiting for changes. It just entirely depends. Right, so there's the other one. Yeah, it might not do it all the time. Yeah, sometimes it does it. It's fine. It's fine. I'll live with the extra line of output. Yeah, it's good to know. Right, so I'm glad that's all working. So I guess let's go ahead and write the new thing, right? So the new thing would be a Clang build, right? Like build in some C code. So I guess what we want to do is go and get the old one, see how many lines it is, and see what I want to do, right? I think I might want to split open. Let's see where Windows H has been included. I think it's only in one place, in the os.c file, right? Just build that one separately, and then build the GPU one separately as well. So that's Vulkan and Windows, done in their own compilation units, and then build everything else in another one, and then link it. That's my current idea. And then things should just be quick. But we'll see. So we need to do some investigation. So the old Clang command used to be this one, right? Build some DLL. So this was the old code for it. So I just want to do really a Clang-E. I think that's basically what I want to do, right? Can I... So Clang-E. I want to do... Yes, let's do code games game -o build test.c or whatever, right? So let's try that. Now I've got to do all these extra things. So if I go to compile flags Windows, these are all these guys, right? So I think we just need the include directories. I think so. Don't do that. Not very nice. Oh, libhmaths, right, slightly spelt wrong. Cool, so let's see how bad my includes are. Here we go. I should really run a poll, but oh well, I missed it. So it's 200,000 lines, okay? So what happens if we only make it include Vulkan, right? What does that look like? So, and I know you can get, yeah, so let's try Vulkan then. So game.c if 0, sorry, if 1 else and if, yeah? We're gonna have a bit of a play here. This will just be include Vulkan core. Right, how big is that? Let's reopen test. Let's do a reload. Right, so it's 10 times less, right? It's 21,000, but still, it's quite a lot. But it's good to know it's not too bad, right? So, you know, I would still rather not include that on everything, right? And it's keeps on growing. I think this is one I've already tried to trim down. Bearing in mind, I've just deleted a whole bunch of stuff because I think it is bigger. So if we try Windows.h now, what is that? Right, so it's like 100,000 lines, right? So that's basically half of everything. So we definitely want this in its own compilation unit. So it's included in Windows. It's also included in Vulkan, unfortunately. And the main game executable also includes it as well. There's also a bunch of C standard stuff too, but in places obviously. We could spend some time to make a custom header, but that's probably going to take too long because my OS layer is quite big, I think. So like, I don't know, it is possible to kind of copy some of this stuff out, right? And put it into my own header. But it could take quite long. Like you just got to do every single function, right? And let's say if there's 3,000 lines, it might not be that bad, right? And then Windows.h should never be included. We should only have a custom Windows header that we use instead. And then Vulkan is it's a lot less, right? It's only 20,000 lines. Yeah, Vulkan is a lot less. So we might not have to care about doing that one for a while. But if we just sort out the Windows one, that would drop lines of code down a lot. Yeah, so let's try and let's try and build the whole thing doing a single build again. And then this small Windows header can be used for the game executable, which is basically just it just loads a DLL, right? And then does a loop, right? It's not really that much code, is it? So including all of this stuff, just get rid of all these headers basically and just do the bare minimum, right? Maybe that'll be enough. So yeah, say if I did a custom Windows header, let's try that. Let's see how annoying it would be. Well, sorry. Let's get it building first, and then we get a time, and then we can do the custom Windows header. So we just want to do a Clang DLL. So I think this is just going to be a single compiling a source file. I don't really want to encourage doing lots of .os if I don't really want to be doing that, right? Because, you know, it's a very big problem when you just build lots of .o files and then you're basically just recompiling all the same code again and again and again. When you might as well just do a single build, right? Right, so let's just do another one. We'll call it CDLL. And we'll just do a single source, you know, source path. So there is a, so we check to see if yeah, so I guess we something like this, yeah. And we want to build the dependency file. So I'll probably just stick it in .c. So yeah, we probably want these two sorts of things. And we'll just stick it in build and whatever the file name is with the extension .d. Now the output file is going to be, so DLL. That'll be without the extension. DLL, yeah. Cool, very nice. Now, if the dependency file exists, it's the same sort of thing again, right? If the dependency file exists, and we're allowed to do a build because we haven't bumped into one of these which pushes on to find dependencies and has poisoned the DAG. So we, you know, if we need to find dependencies, we might as well not run the DAG anymore. So we just basically skip trying to build it and finish it quicker. And right, so this means we want to try and launch it. So this, we'll just call it a CDLL. Input file path. Now we're going to find the Clang DLL one, which I had before. So this, yeah. This is basically it here. Take this with us. Lib name. Right, it's be called lib. Okay, what's this lib name thing? Cool. So get rid of that lib thing. And right, so -o. Okay, so it looks like we'll do a string format for the dependency file, and then do a string format for the DLL file path, yeah. And I guess again, we'll do another string format for the input. Okay, so let's say dot star s, dot star s, dot star s. Then these are just a bunch of like flags and stuff, right? So I've got these sort of like compile flags and things which are just initialized at boot, and then it reads from the so it reads it from that sort of compile flags.windows x64. Lovely, lovely, lovely. So then it copies it as well. The build system will copy it to the dot compile flag, so my editor picks it up. Right. This is kind of cool. So string command. Perfect. So I guess we can try and indent it a bit. Make it respect, you know, to do what the other ones are doing kind of thing. Whatever that'll do. So, well, okay, so if we take this, we'll just put it in here now. And we're going to make a new input node. The output's going to be the DLL. So I could have probably just called it output. Make it a little bit more generic. You know, you can have multiple inputs and outputs, right? But if we only have one in and one out, you might as well just probably not really bother naming it. So let's find that spear v1, so that's output. Right, so that's for the shader compile. All right, so now we need to do a dry run pass. If yes, this is fine, right? It's gonna run it now. This be a dry run pass. If the dependency file doesn't exist, this would be for like a clean build, or if you delete it, right? So it should be the same thing basically, but so we might have to strip out some of the lib stuff as well, but it might be okay to run with it anyway. But you want to run it with a -m instead and ditch the output file. Now what ended up happening, sorry, the deps file one here. So what basically happens on GLSLC is it didn't like me manually defining the output file. So basically I did a redirect to standard out, and then I've made that as part of, so you can't do it here as part of the command, right? You know, redirect to a certain path, right? So it'll be something like lib game dot, well, sorry, it'd be like game.c.d, right? The dependency file. But unfortunately, I couldn't do that because of the way create process works. So I've just had to manually pass in the file path here. And when I launch the command, so standard out file path, when I launch the command in the executor, which is the background thread, which wakes up when stuff is not running and tries to put more work on. So before it does create process, it creates a new standard out file, and it will set them up as the standard out and standard error. And then, yeah, if that's a create process, and then it writes to the file that way. But it works. It's the main thing, and it seems to be performance. So, right, so this is the new one, the new command. It didn't take too long to do there, which is great. So we want to try it out. So we're going to try out So yeah, currently all of my builds will end up linking and compiling it's the same libraries and stuff, but stuff we can sort out another day, right? So code slash game slash game slash game. Let's try that. What else are we trying to do? Yeah, I think there was another thing as well that yeah, I think when we get copy, we want to make sure we can copy the compile flags to .txt, but we'll do that. Yeah, this is the old code. Just got to remember to sift through the old code and make sure everything ports over. So here we go. Right, so what did this complain? Can I open file libgame dot bit weird. Let's run it again, see what happens. Did I break the build script? Oh. It ran a second time. Now that's very questionable. Oh, it might be because it was trying to do the dependency pass. Oh, that's really weird. Oh, right, it might have had an old .d file. Anyway, let's delete everything. Try that again. So, delete. Alright, so part of the issue when we write standard out is... did I write the error into here? No, I didn't. Cool. Did it. So... yeah, so now what we can do is simply, like... yeah, delete all that. We can go to... yeah, it might be nice to maybe add into the build system way to like trigger rebuilds and stuff. But maybe we can just delete files and it starts doing it anyway. But yeah, we want to do a verbose so we can catch it, right? So now we're looking for game.c. Right, this is the one we ran, I think. Right, why doesn't this work? It does. That's not very nice. Oh, okay, so... right, so you can't use linker stuff. Yes, this isn't very nice. I don't like this. The fact that it's not showing up. So it might be because I've taken out standard error as well. So I want to redirect. Hang on a minute. So when I have a standard out file thing, I want to give it the one of the build script so it points to... I think that's going to do it right. So I delete that. Yeah, perfect. You see it here? It's done it. That's cool. So yeah, well, link errors. That's all right. So we shouldn't be putting these out. Now, where do we control that? Right, what do we do? So, how did I do it before then? Did I have it? I had a dependency file. But what happened? So this is the old system. Well, I think I've not got the code anymore, maybe. Oh no, it would just run it regardless with the same command. Right, so we've done something a bit different now. So now we run a separate pass before building it if it needs to happen. Does this mean the libraries and stuff that it links to? Okay, so I think we've got to be a little bit more intelligent on how we do this. So we might have to pass in like stuff we want to actually link against and include. So we'll probably have an array of include paths, an array of library stuff, right? Maybe. And that might be the way to go. Yeah. Let's just get all of this and just chuck it into a string and just throw it in. We can fish it out. Yeah. So let's just grab all this. And then we want to... So you need to have your commands. So we have two commands, right? So we have a char. You want args, and then you want a find depths args. Those are the two things you need. So which ones don't we need for the find depths? All right, so let's just join it up. So this one's the... Right, so char star. This is just args. You know, we can try and make this better if we need it in the future, but this should just be sufficient for a very long time. So where is... So we don't need any of the library link bits, basically, but the rest we should probably have. So args, find depths args. All right, let's try that out. So we'll go over to here and, oh, that uses fpic. I'll get rid of that. Platform args. Run out loud. Let's drop them in here as well. Lovely, right, so we just completely changed all this. So we just need one string for args. And that's it now. There is debug args actually. Right, okay, so we will have another one. Okay, so when it comes to find dependencies, we just do the find depends args. And we probably don't need shared then. Let's try that. Cool, so if I delete this .d file and this DLL and all that, right? What happens? Okay, so it failed again for some reason. But it kept building it a few times, so the define deps ran. You know, it's not a bad time. It's only taken a quarter of a second, so maybe I don't need to change all the header file stuff then. I don't know why I was thinking it's too slow. Maybe it was something else that was the problem. I'm very confused now. But okay, maybe it was something to do with the build system beforehand. But now this new version just fixed it up. That's great. I don't have to mess around with the headers. Potentially. There was the exe as well I need to look at. I'll need to build too. This is great. But yeah, why doesn't it work? Can I open file? That's not great. So it must be because so my old build system I might have had a sleep to solve problems like this one that we're encountering. It might be what's going on. So it might have accumulated, so it had been more than a second or two. Okay. Yes, this seems like what's going on. So if I was to change it with -v, alright, so we try this out. Right, here we go. So this one failed. -v is not very helpful, I don't think. It would be nice if you told me what file is the problem. Oh, so pinpoint when... Oh, it does it? Right. So do you reckon it's trying to run the build twice, maybe? So it ends up. Yeah, I think that's what's going on. So it's actually trying to trigger two builds. Like it's not waiting for the execution to be finished, maybe? That'd be weird to me. Let's see if that's the case. Yeah, so we're going to execute a wait. So it should be a wait in there. Hmm. Right, so if I delete the dealer, what happens? Nothing. That's questionable. There's that too. That should be picking up stuff. But it's not. Wait on the watch. Right, this is because it's not. Yeah, we should be watching directories as well. So when we do a file index, the file indexing, we should be right away here. We should be watching it. I think that's what you want. Yeah, that's good. It crashed though randomly for some reason. Ah, so it must be doing a lot of allocation then. 8 megabytes worth of allocation though? Seems questionable to me. Well, yeah, that makes sense. These, right, I see what they are. Yeah, this adds up pretty quick. Right, we need more than 8 meg. Let's just do 64, might as well. Should know it, right? Wow. Oh. So yeah, it seems like we've got a lot of file directories that we're waiting on for some, we're watching. Is it a dash V maybe? it's not too bad. Not sure where the allocation is. Good change though. Ooh. It keeps doing build tag, build tag, build tag. That means we must be seeing more file changes. So we're not logging those. That would be useful, right? You know, we've got to change. Their event type strings. And then we can just log it, right? So I guess we log it here, so log v. So for verbose only, we'll say directory event, one of these, and then this. There'll be directory event type string. So e type and then e path. Right. So now the dag.dot file keeps getting changed. And then it's like, hey, you need to rebuild everything. It's like, ah. Right. I see now. So then that keeps causing allocations. And then eventually it runs out of memory. I wonder if we should like string deduplicate some stuff as well. Because then it will like save memory, but I'm not really interested in saving memory sometimes, you know? But yeah, things to think about. But this is a good place to probably put a pin in it. So we're pretty close to getting C code compiling again. And after that, it's basically copying files over. So we do copying assets because that's what's left of the build system. And then probably we delete the rest of the old code, and that's just sort of hanging around, like all this here. Basically just double check we've got everything in. And then work on the inter-process communication. So it's basically just like a ring buffer that is a memory mapped file, and the game has it open and the build system has it open, and they communicate. So we'll just build that. Hopefully next stream we'll get it started. So next stream is Friday, so tomorrow at 2 p.m. GMT +1. in the meantime, guys, there's Discord if you want to come chat. And yeah, if you want to support the project as well, feel free to head over to the Ko-Fi page and pick up the membership. And when this build system is done, is very soon, sometime next week, I imagine. The code will be up there to have a tinker and play with on your machine. So yeah, but yeah, it's looking good. I'm really liking these times that we're getting showing up, so we can see now how long these commands are actually taking, and it seems quite positive. But yeah. Right, I'll see you guys all tomorrow, hopefully. Hope you have a lovely sleep. If not, I'll see you all the next day. God bless you all. Remember, Jesus Christ is the way, the truth, the life. The only way to the Father is through the Lord Jesus. He is the in his sacrifice is the forgiveness of sins. It's by that blood payment alone our sins are forgiven, and when we have faith in that, our sins past and future have been forgiven. But yeah, in your own time, go before your bed at night and just pray to God and say, Lord God, if you're real, reveal yourself to me, help me know the truth, and help me not believe a lie, but rather be with you in heaven or on the earth in your reign, in a glorified body without suffering, without any sin. And yeah, and just be honest, open up to God and say, Lord, how can I possibly believe if you're real? If there's a common one that people struggle with is if there's wars going on in the world, right? How can I believe in God if there's wars in the world? How can I believe in God if there's chaos? Right? Just be honest with God, open up and pray to Him, and He will put the answers in your life in due time, and He will reply. But yeah, keep seeking. There's a Bible verse, Jeremiah 29:11-14. For I know the thoughts, this is God speaking, for I know the thoughts that I think towards you, says the Lord. Thoughts of peace and of evil to give you a future and a hope. And you will call upon me and go and pray to me, and I will listen. And you'll seek and find me when you search for me with all of your heart. And that's the promise of God. Seek and find with all your heart, you will find him. And he wants to give you a future and a hope. So if things are not in the future, not looking hopeful, seek God. Anyways, God bless you all. Hope to see you tomorrow. If not, I'll see you all Sunday. And yeah, have a good night.